Welcome to part two of the 2018 ELEC 327 How to Solder Surface Mount Integrated Circuit video. Your host is Professor Kamiri, and what I'm showing you here is the Lab 2 printed circuit board, which I introduced in part one, and an MSP430G2553 part, which is a surface mount 20-pin part. So you can read the part number on it, and then you'll also notice right underneath my tweezers is a small dot. That dot wants to line up with the dot on your printed circuit board. So what I'm going to show you today is drag soldering. So drag soldering is a really nice, easy way of quickly soldering something like this with pins in a row, surface mount. The way that I do it is that I initially solder down the corners, so the opposite corners of the device, just two of them, and then put some flux down, and then I'll show you my technique for drag soldering. So let's begin by soldering down pin 1, which is the pin with the circle target on it. Okay, so something that's important is to understand how to properly use the soldering iron. So this soldering iron has a bent tip. In general, with any soldering iron, the tip is not the part that you want to solder with. So you don't want to treat this like a little beak and touch it to the thing that you're trying to heat up. Instead, what you want to do is you want to use the side of the soldering iron to transfer heat to the printed circuit board or to the PCB. Now, this is much easier if you use the microscope. So while I did that, so what did I do? I put the soldering iron down, heated the pad, and then put a small dot of solder on it that I'm then now going to reheat when I put the device into place. That was much easier because I was using the microscope that I'd set up in part one of the video to focus here on the exactly into this center part of the PCB. Okay, and when you do this, you also want to rest your wrists on the ground so that the only thing that's supporting the soldering iron tip is just your fingers. That way, even if your hands shake a little bit, you will not have that much trouble in holding it steady. Okay, so now what I'm going to do is I'm going to bring in the MSP430 close to where I want it to go. I'm going to hold the soldering iron down on the solder that I just deposited there so that it melts. And then I'm going to bring the MSP430 into place. Now, the key when you're soldering is to remember that solder has surface tension, and so it will tend to try to pull things along. So what you want to do is you want to remove your soldering iron before you remove your tweezers, which are holding the device. If you do it in the opposite order, if you remove the tweezers and then remove the soldering iron, what you'll find is that often whatever it is that you're trying to solder will go along with it. Okay, so now I've soldered one corner, and I'm going to solder the pin that's on the opposite corner. So now here, I'm going to bring in the edge of my soldering iron so that it's touching the pad and the pin. I'm just going to dab a small amount of solder into place. So now when I look down, I see that the pad is not really tinned with solder yet, so I think, okay, all I did was heat the pin as opposed to the pad, so I'll bring in a little bit more solder. This solder has flux in it, so it conducts heat really well. And so what you'll see now is that there's a small liquid spot that's from the flux that was deposited when the solder melted. So now there's a blob of solder that's connecting the pin and the pad. And just to make sure that the device is flat, what I'm going to do is I'm going to come in and I'm going to melt it again, and I'm going to push down on the MSP430 with my tweezers. That makes sure that even if it was slightly bent up after I'd soldered the far corner, that now it's in the right orientation, flat with all of the pins. And so what you can see is I've nicely lined up all of the pins with the appropriate pads. And now we're ready for phase 2, which is drag soldering. So what we're going to do for phase 2 is that we're going to squeeze some flux on. So this is a syringe. I'm going to scrape off the tip of the syringe, and then I'm going to just push the syringe just a little bit and put a small bead of flux down on top of all of those pins. Now I'll come and I'll tin tinning means putting solder onto your soldering iron tip. So I'm just going to put a nice blob of solder onto my soldering iron tip. and then I'm going to bring it in, and while looking under the microscope, I'm going to scrape this tip across these pins. So what you see is a big mist of flux rose up into the air, and as I dragged the tip of the soldering iron on, the fact that copper absorbs heat better than the fiberglass in between it caused the solder to flow onto the pins and pads of the PCB. And so what you'll see is that each of the pads has a nice silvery hue now as opposed to the previous gold hue, and each of the pins has a little blob of solder on it. I'll zoom in here so that you can see a little bit better. Okay, so now I've zoomed in on the MSP430, and I've cleaned it off already a little bit with an alcohol wipe, so I can clean it off a little bit more. Alcohol wipes are really nice because the alcohol in them dissolves the flux and cleans up the board, and then you're left with something that's really nice and clean. Okay, so what is the normal failure mode for drag soldering? The normal failure mode is that you have solder bridges where a ball of solder connects two pins. So right here you can actually see a little jag of solder that looks like it's trying to connect these two pins. And I'm going to make that worse here, and then I'll try to make it a little bit better. All right, so now you can see we have a bridge. So what do we do about solder bridges? Well, the easiest thing to do for solder bridges is to put a little bit of flux down on top of them, and then to clean them up with solder wick. So solder wick comes in a roll, and at the end of the roll there's a little tab of just basically braided copper wire, very small copper wire. And what you want to do is you want to make sure, if somebody's used this before, that you take a pair of scissors and you cut it off so that the copper wire is clean at the end, it doesn't have any solder on it. Then what you do is that you bring it in with if you're right-handed, you bring it in with your left hand, you hold it right next to your solder bridge, and then with your right hand you come in with your soldering iron and squish down on it. And what will happen is that the flux will transfer the heat to the pads, and the solder will wick just like a liquid, I guess because it is a liquid, up into this copper braid and off of where it was connecting the pins. And so now what you can see is we've got a really nice connection here where there's just enough solder to connect between the pad and the pin of the MSP430, but no solder connecting them across the pins. Quick aside here, when you take the solder wick off, make sure that you keep your soldering iron on it so that the solder stays liquid and the solder wick comes off really easily. If you take your soldering iron off and leave the wick in place, then the solder will harden and the wick will become attached to your chip. So if you see that happen, if you try to pull it away and you realize it takes some force, don't tug on it because that can rip pins off or mess up the PCB. Instead, just rehit it with the soldering iron so that it heats up, and then pull it off gently. All right, so I did this for one side, then I can do it for the other side. I'm not going to show that in the video. And then the next thing that I'd want to do is to solder in the programming resistor and header so that I can test to make sure that my MSP430 can communicate with a launch pad for programming. And then when that is done, then I could go through and solder on all of the other parts. So I hope that you've enjoyed this video. Please feel free to comment or like, and we will also follow up again in class next week. Thanks very much. Have a good day. Bye.